Hey y'all, welcome back. So on tonight's homework, we are practicing using the power rule and looks like a little bit of other derivative practice, but for the most part, we should be just using the power rule. Number one, we've got 5x plus 8 times 2x minus 6. We're going to multiply both of these binomials together using the distributive property on each term in the first binomial. So y is going to equal 10x squared minus 30x plus 16x minus 48. Combining those like terms is going to simplify this linear term right here. What would that be? Negative 14x. And now I'm ready to find the derivative. I'm going to use that power rule. So y prime is equal to 20x minus 14. Number two, I'm going to rewrite these square roots as, or not all square roots, but all the roots, all these radicals, as rational exponents. So f of x equals 12 times x to the power of 5/3 minus x to the power of 1/2 plus 5. And I can just go ahead and use the power rule. So f prime is going to be 12 times 5 is 60/3 x to the power of, let's see, 5 minus 3 would be 2, so 2/3 minus 1/2 times x to the power of negative 1/2, and then the derivative of a constant 0, so we're just going to leave it at that. Now, just taking a second look at this, one thing I could have done is 60 divided by 3. I mean, you could leave it as 60/3, but I'm going to go ahead and just write that as 20. I don't know. It's just so easy to do in your head that I think it's kind of worth it. But you wouldn't have to on a free response section. So h of x equals x. Okay, so we don't really have to do anything here. It's just the slope of this linear function is 1. There we go. 4. Okay, here is where we're dividing a polynomial by a monomial. So we're going to divide each term by that denominator. Each term in the numerator divided by each term in the denominator. So we get 3x squared plus 2x to the negative first power plus 4 divided by 2 is actually 2. Oh, come on. There we go. 2x to the negative third power. So now we can apply the power rule to get our g prime. It's going to be 6x plus negative, I guess we just write minus here, minus 2 x to the negative second minus 6 times x to the negative fourth. For number 5, we need to go ahead and distribute this negative 3x to the third. So f of x equals negative 6x to the fifth plus, nope, not plus, minus 15x to the third. Applying the power rule is going to give us negative 30x to the fourth minus 45x squared. Okay, number 6. We've got these fractions with exponential, or not exponential, but terms with exponents in the denominator. So we can rewrite those using negative exponents. Y is going to be 3 times x to the negative fourth plus 5/2 times x to the negative second. In that case, y prime is going to be negative 4 times 3 is negative 12, x to the negative fifth minus 2 times 5 is going to be 10 over 2. So that's just going to be minus 5x to the negative third. Number 7, determine the equation of the line tangent to the graph. Okay, we've seen this a multitude of times at this point. This should be no surprise. The equation of the line tangent to the graph. We're getting our point slope form here set up. And don't forget, we get the point from the actual function itself, and we're going to get the slope from the derivative, because that's what the derivative is. So f of x, after we distribute this in, not distribute the f of x in, distribute the 3x. Let's try that again. There we go. Is going to be 12x minus 6x squared. So our derivative is going to be 12 minus 12x. So let's find our point and our slope. To find the point, it's going to be the point at x equals 2. We're going to plug in 2 into f. So we're going to find f of 2. The slope at x equals 2 is going to equal the value of the derivative when x is 2. So the slope, and I'll color this in blue just to emphasize where we're getting it from, is going to be f prime of 2. Okay, so we're going to plug those numbers in as soon as we find them, but we got to actually figure out what they are. So if I substitute 2 into f of x, that's going to be 24 minus, is that 24 minus, hold up. It'll be 24 minus 2 squared is 4, times 6 is 24. Is it just 2 comma 0? Yeah, I guess so. And then the slope is going to be the slope when x is 2. I'm going to substitute in that 2 into my slope formula. So I get 12 minus 12 times 2, which is 12 minus 24. That's going to be negative 12. So now I can go ahead and write my equation in point slope form over here. Y minus 0, so it's just going to be, I'll just write it here for now, but I'll probably erase that at the end, equals negative 12 times x minus 2. So that's it. You can leave it like that. You might be tempted to just go ahead and erase that minus 0, which is totally fine. I do that. I do the same thing. But yeah, there's your equation. Number 8 says if f of x equals this function, then what is f prime of 2? In other words, what's the slope when x is 2? So let's first rewrite this using negative exponents, 4x to the negative second plus 1/4 times x squared plus 4. Apply the power rule to find the derivative, negative 8x to the negative third plus 1/2, 2 times a fourth is a half, times x to the first plus 0. So if I want f prime of 2, I just need to substitute 2 in here. Ooh, this is going to be a little, okay, without a calculator, this is going to be a little tricky, but let's see if we can do it. Negative 8 times 2 to the negative third plus 1/2 times 2. The only thing that's really throwing me off here is that negative third power. So I'm going to try to rewrite that as a fraction and see if I can't make more sense out of that. So that'd be 1 over 2 cubed plus half of 2. I can do that. That's just 1. Now 2 cubed is 8. So what we have here is negative 8 times 1 over 8 plus 1. So this is actually going to work out pretty nicely because 8 divided by 8 is just 1. So we have negative 1 plus 1 is 0. Number 9, use the data in the table to estimate the slope when t is 4. Indicate units in your answer. Okay, so this is meters and years. We don't really have too much context other than that, but we want to estimate the slope when x is 4 or t is 4. So 4 would be right here. So what we're going to do is we're going to find not the instantaneous rate of change, but the average rate of change. So we find the average rate of change when we find the slope between 2 points on the curve, find the instantaneous rate of change when it's actually at the point we want. So since we don't really have enough information to know exactly what the slope is at 4, so we're going to find the average rate of change of the 2 points that are close by. So in other words, we're going to use these 2 points. So we're going to estimate the slope when x is 4 by simply using the slope formula. Okay, so that would be 6 minus 2 over 5 minus 3, which would be 6 minus 2 is 3, 5 minus 3 is 2, so yeah, 3/2. Now, if we want to say, what kind of, wait a minute. That's a 4, geez. And that's going to be 2. So if we want to say the units, because it does say indicate units in our answer, this is going to be meters per year. Okay, or you could just write like 2 meters per year. Either way is fine. I usually will just abbreviate here, but you can write it out if that helps you make sense of the problem or your answer. Number 10, find a parabola with this equation that has a slope of 4 at x equals 1. Okay, a slope of -6 at x equals -1, and passes through the point 2, 15. Whoa, this is a lot of information they're giving us. Okay, so we're not trying to find the equation of a line here. We are trying to find the equation of a parabola. Y equals ax squared plus bx plus c. And so we're going to need to figure out what a, b, and c are. Now what we know, and maybe I'll just go ahead and write it like that. What we know is that the slope what the slope at 1 is. So y prime at 4, y prime at 1 is 4. Okay, the slope when x is 1 is 4. We also know that the slope when x is -1 is -6. And we also know that y of 2 is 15. So we're going to have to use these 3 pieces of information to figure out what a, b, and c are. So let's use these facts to see if we can't work our way back to the a, b, and c. So first we know that the slope when x is 1 is 4. So let's first find what is that slope equation. So if this is y over here, so if y is ax squared plus bx plus c, y prime must be 2ax plus b. So if we know that the value of the slope is 4 when x is 1, so in other words, our y prime is 4 when x is 1, we get a nice little relationship here between a and b. That's not going to actually give us a or b, but it's going to help us figure out what a and b are. The second piece of information that we got was that the slope when x is -1 is -6. So -6 is going to equal 2a times -1 plus b. All right, so here, once again, we've got another equation that relates a and b, but doesn't actually give us a or b. But now what we have here is a system of equations. We've got one equation that has a and b, and we've got another equation that has a and b. And if we put these 2 equations together in a system, we can solve for a and b. I have to zoom out a little bit here, get myself some room. So here's my 2 equations. We've got 2a plus b equals 4, and -2a plus b equals -6. There's a variety of ways that you could solve this system, but because they're set up where one of the coefficients or one set of coefficients are opposites, we've got the 2 and the -2, I'm going to use elimination. So I'm going to combine these 2 equations. 2a minus 2a is 0, b plus b is 2b, and 4 minus 6 is negative 2. So that tells me that b is negative 1. Now that I have b, I can figure out a by plugging in this negative 1 into really any of these equations that I started with. So I can put this, let's say, here, and get the equation 2a minus 1 equals 4. Adding 1 to both sides gives me 2a equals 5. So a's got to be 5 halves. Now that I've got a and b, I can find c, because what I know is that the value of the function is 15 when x is 2. So in other words, y equals, I know my a is 5 halves, x squared. I know my b is negative 1, so this is going to be minus 1x plus c, right? And so when x is 2, y is 15, that's where I'm going to get the c from. So the y is 15, the x is 2, and now I've got an equation that I can solve for c. So 2 squared is 4, 4 times 5 would be 20, divided by 2 is 10, 10 minus 2 is 8. I'll just go ahead and change that. 10 minus 2 is 8, plus c. So yeah, I can solve this for c. It's 15 minus 8 is 7. So now I've got a, I've got b, and I've got c. So I've got all the pieces I need to write my parabola. Y equals 5 halves x squared minus x plus 7. Ooh, that was a tough one. Number 11, determine this following limit. Well, we talked about in class how we're not going to really be seeing any, find the derivative using the limit definition kind of problems. But what we are going to see is a question like this where it kind of looks like they're just asking for a limit, like it would be a question that you would see in Unit 1 where we're talking about limits. But I really don't want you to solve that, this like we did before. What I want you to do is recognize that really this is just an instance of the limit definition of the derivative. So, like in other words, the limit definition of the derivative is going to look something like this. F of x plus h minus f of x all over h as the limit approaches, as h approaches 0. So you can kind of see how this function kind of looks like that. We can see our f of x plus h here, right? And then we can see our f of x right here. So to find this limit, instead of doing all the algebra and going through the limit process, we're just going to recognize that this is just asking for the derivative, or so dy or dx of f of x, which is 3x to the 5th minus 4x cubed. So we're just going to differentiate this. So we know how to do that. We've got the power rule. We've got 5 times 3 is 15. We've got x to the 4th minus 12x squared. Number 12, determine the equation of the normal line. So we talked about how the normal line is the line perpendicular to the tangent line. So basically what we have to do is find the slope of the tangent line and then negate it, reciprocate it, and that'll be the slope of the normal line. So we're still, at the end of the day, writing the equation of a line. It's going to be in this form y minus y1 equals m times x minus x1. Let's find the point first. So f of negative 2, here we go, find the point. F of negative 2 is going to be negative 3 times negative 2 cubed plus 2 times negative 2 plus 7. Negative 3 times negative 8 minus 4 plus 7. So So that's going to be 24 minus 4 plus 7. That's going to be 27. All right, so now I've got my x1, my y1. I've got my x1, my y1. Now I need to find my slope. So that's going to be the slope when x is negative 2. So first let's find the equation of the derivative. F prime of x is equal to let's see, 3 times 3 is 9, so negative 9x squared plus 2. So f prime of negative 2 is going to be negative 9 times negative 2 squared plus 2. Negative 9, times 4 is going to be negative 36. Negative 36 plus 2 is going to be negative 34. Now, that's not going to be the slope we want, though. This is going to be the slope of the tangent line. So just to be clear, this is the slope of the tangent line. What we want is the equation of the normal line. Normal line. And the normal line is the line that's perpendicular to the tangent line. So the slope is actually going to be positive 1 over 34 because that's the opposite reciprocal of negative 34. So my final answer here should be y, let's use an actual pen here, y minus 27 equals positive 1 over 34 times x plus 2. Number 13. And this is our last problem of the homework. It says, for what values of x does the graph of this have a horizontal tangent line? So we've been asked this before. We should expect to see a question where it's asking about horizontal tangent lines. And that's when the slope equals 0. Okay, so if you've got like a curve that does something like this, if we have a local maximum, local minimum, or change in concavity, we're going to have a horizontal slope, potentially. Okay, so let's go ahead and find the derivative here, because that's going to give us the slope. So the slope here is going to be 6x squared minus 7x minus 5. And we want to know, when is that 0? Ooh, this is the first time, I think, that we've had to factor a quadratic where the a value is not 1. And we didn't have any hints. Like back when we were factoring some of those limit problems, there's always like a hint as far as what one of the factors are. This one we're just going to have to figure out. So I'm gonna do this by grouping, I suppose. 5 times negative 5 is negative 30. So this is my a times c. And then my b term, my middle term, is negative 6. So what I want are two numbers that multiply to give me negative 30, but add up to negative 7. So what would that be? Like 6 and 5 isn't going to work. 10 and 3. So it's got to be negative 10 and 3. So these two numbers that I just found here are going to be how I split up that middle term. So 6x squared minus 10x plus 3 minus 5. And now I'm going to group the first two terms and the last two terms. And I left off an x on that 3, it looks like. I'm going to factor out the GCF out of each group. So out of the first group, I can take out a 2x. And the second group, I can't really take out anything, so I'm just going to factor out a 1, since anything has a factor of 1. So at this point, I can factor out the 3x minus 5 as though it's a GCF, and that leaves me with the remaining factor, 2x plus 1. So the two values that are going to, let me put it this way. The two x values that the graph has a horizontal tangent line at the following two x values. Geez, let me try to get that out. So 3x minus 5 equals 0, and 2x plus 1 equals 0. We can solve each of these, and we're going to get 5 divided by 3 is 5/3. And then we also get x equals negative 1/2. Now this might be a case, I know a couple of y'all have tried to use quadratic formula. feel free to use quadratic formula right here. If you are a little shaky at factoring, you are welcome to use the quadratic formula if you need it. It's not something that's required, but it's there if you need it to fall back on. Well, that's it for tonight's homework, y'all. Thanks for watching, and I'll see you next time.